Good morning, my dear students. In the previous class, we discussed ionic bond and its formation, properties of ionic compounds. In this class, I am going to discuss covalent bond. Okay, see, covalent bond. We know ionic bond is formed by the complete transformation of electrons from one atom to another atom. But covalent bond is formed by mutual sharing of pair of electrons, that is bond pair of electrons between atoms. Okay, so in the formation of covalent bond, generally what happens, one atom contribute one electron, another atom contribute one electron, so both will form bond and the bond pair of electrons shared between two atoms. Okay, example, let A contains one unpaired electron in its valence shell, B also contains one unpaired electron in its valence shell, and both, so A contribute one electron, B contribute one electron, and both will form bond, that is bond pair of electron. This is bond pair of electron B, and this bond pair of electrons shared between two atoms A and B. So this is covalent bond, that is covalent bond. Generally, only unpaired electrons of atom involved in the formation of covalent bond. Unpaired electrons involved in the formation of covalent bond, and the number of covalent bonds formed by an atom is equal to number of unpaired electrons. Number of covalent bonds formed by an atom is equal to number of unpaired electrons. For example, phosphorus, and take phosphorus, atomic number Z is equal to 15, valence state configuration 3s2 3p3. In the ground state it has 3 unpaired electrons. That's why it can form 3 bonds in ground state. Now coming to the excited state 3d 0 also. Now one electron jumps from 3s to 3d, then 3s1 3p3 3d1. One electron jumps from 3s to 3d, then number of unpaired electrons, now number of unpaired electrons 5. So now it can form 5 bonds. Here forms 3 bonds, here forms 5 bonds, because in the ground state it has 3 unpaired electrons, that's why it can form 3 bonds. In the excited state it has 5 unpaired electrons, that's why it can form 5 bonds. So generally number of covalent bonds formed by an atom is equal to number of unpaired electrons. Okay, now let us discuss about single bond, double bond, triple bond. Single bond. Okay, a single bond is formed by mutual sharing of pair of electrons. That means two electrons. For example, formation of H2 molecule. We know in hydrogen atom, atomic number 1, electronic configuration 1s1, it has one unpaired electron. Okay, one hydrogen atom has one unpaired electron, another hydrogen atom also one unpaired electron. Okay, so one hydrogen atom contribute one electron, another hydrogen atom also contribute one electron and forms bond. This is H. This is pair of electron, bond pair of electron. So this bond pair of electron mutually shared between two hydrogen atoms and also written as H bond H. So in the formation of H2 molecule, single bond is formed or double bond is formed or triple bond is formed. Single bond, one bond between two atoms. Okay, some more examples. The formation of single bond. Example, Cl2 molecule. We know chlorine atomic number Z is equal to 17, valence state configuration 3s2 3p5, 3s2 3p5. In the valence shell, it has one unpaired electron. That's why one chlorine atom, one unpaired electron, and also three lone pairs. Okay, so total 7 valence electrons. In 7 valence electrons, 3 lone pair of electrons and 1 unpaired electron. Plus another chlorine atom also contains 1 unpaired electron and 3 lone pairs. Now forms Cl2 molecule. Then so this is bond pair. Now chlorine gets octet. This chlorine also get octet. 2 plus 2 4, 4 plus 2 6, 6 plus 2 8. 2 plus 2 4, 4 plus 2 6, 6 plus 2 8. Okay, so Cl2 molecule. This is Cl bond Cl. Chlorine molecule. In the formation of chlorine molecule also, how many pair of electrons shared? One pair of electrons shared, that is 2 electrons. Okay, next in the formation of F2 also, one pair of electrons shared. The single bond is present between F and F. Okay, next formation of HF. Molecule. We know fluorine atomic number Z is equal to 9, valence state configuration 2s2 2p5. It has one unpaired electron and 3 lone pair of electrons in the ground state. Okay, now hydrogen atomic number Z is equal to 1. It has 1s1 configuration and has one unpaired electron. Now hydrogen contribute 1 electron plus fluorine contribute 1 electron, and this is unpaired electron and 3 lone pairs on fluorine atom. 3 lone pairs. Now H and F. So H contribute 1 electron, fluorine contribute 1 electron and form bond between hydrogen and fluorine. Hydrogen get doublet configuration, fluorine gets octet configuration. So this is H bond F. Okay, so this bond pair of electrons mutually shared between H and F. So this is formation of single bond. Examples H2, F2, Cl2, HCl, HF, like that. Okay, now let us discuss double bond formation. Double bond. Double bond formation. Okay, example, formation of O2 molecule. Okay, see, oxygen atomic number 8, valence state configuration 2s2 2p4. In the valence shell, how many unpaired electrons present? In the valence shell, how many unpaired electrons present? 2 unpaired electrons present in the valence shell. Okay, now so in the formation of O2 molecule, 2 oxygen atoms involved, one oxygen atom. See, these are lone pairs, 1 lone pair, 2 lone pair, 1 2 and 2 unpaired electrons, and another oxygen atom also has 2 unpaired electrons, 2 lone pairs and 2 unpaired electrons. Okay, so this oxygen atom contribute 2 electrons and this oxygen atom contribute 2 unpaired electrons. Then see this. Now this oxygen has 2 lone pairs and this oxygen also has 2 lone pairs. So here this is one bond and this is one bond. Total double bond is formed between two oxygen atoms, written as like this. Two lone pairs on each oxygen atom. Now each oxygen atom gets octet. Okay, 2 plus 2 4, 4 plus 2 6, 6 plus 2 8, 2 plus 2 4, 4 plus 2 6, 6 plus 2 8. Each oxygen gets octet. So this is the formation of double bond. Okay, one more example to the formation of double bond: ethylene. Ethylene example: C2H4, C2H4. In between carbon and carbon, double bond is formed. Between carbon and hydrogen, single bond is formed. Okay, one more example for formation of double bond: ethylene. Between carbon and carbon, double bond is present, and with the hydrogen, single bond is formed. Okay, so double bond is formed by sharing of two pair of electrons. Sharing of two pair of electrons. Two pair of electrons. Okay, that means 4 electrons. Two pair of electrons, that means 4 electrons shared between two atoms. This is the double bond formation. Let us discuss triple bond. Okay, see, triple bond. Triple bond means sharing of 3 pair of electrons. Sharing of 3 pair of electrons. That means that is 6 electrons. Sharing of 6 electrons between two atoms. Example: N2 molecule. Example: N2 molecule. Nitrogen, atomic number 7, electronic configuration, valence state electronic configuration 2s2 2p3. It has 3 unpaired electrons in its valence shell. Then another nitrogen atom also has 3 unpaired electrons in its valence shell. Then this electron with another electron in the another nitrogen atom form one bond, and this electron with another electron in the another nitrogen atom 2 bond, and this electron with another electron in the another nitrogen atom 3 bonds. And also this nitrogen has one lone pair of electrons, and this another nitrogen also one lone pair of electrons. So triple bond is formed. Total here how many pair of electrons shared? 3 pair of electrons shared. 1 2 3 between two atoms. 3 pair means 6 electrons shared. 3 pair of electrons and 6 electrons, that is 6 electrons shared between two atoms. More example: HCN. In HCN, the triple bond is present between carbon and nitrogen. Okay, next acetylene. Acetylene formula: C2H2. In acetylene also there is a triple bond between two carbon atoms and the single bond between carbon and hydrogen. This is the structure of acetylene. So triple bond is present between two carbon atoms, acetylene. Okay, so triple bond is formed by sharing of 3 pair of electrons, that is 6 electrons between two atoms. Example: N2 molecule. Example: HCN. Example: acetylene. Okay, so these are formation of single bond, double bond and a triple bond. Okay, let us discuss types of covalent bonds. Generally there are two types of covalent bonds. One is polar covalent bond, another one is non-polar covalent bond. Polar covalent bond. Polar covalent bond means, this is also called polar covalent bond. It is formed between two different electronegative atoms. It is formed between two different electronegative atoms. For example, HF. This is polar covalent bond. Hydrogen electronegative, fluorine electronegative, different. They have different electronegative values. HF, HCl, HCl, H2O, SO2, SO2, H2S. In all these, polar covalent bond is present. So covalent bond is formed between two different electronegative atoms. In this one, what happened generally? So this pair of electrons, fluorine has more electronegative than hydrogen. That's why this bond pair of electrons attract towards fluorine atom. Then fluorine gets partially negative charge, hydrogen gets partially positive charge. That means here pair of electrons near to fluorine atom. So fluorine gets partially negative charge, hydrogen gets partially positive charge. So this is polar covalent bond. Polar covalent bond means this covalent bond formed between two atoms with different electronegative atoms. Okay. Now non-polar covalent bond. Or pure covalent bond. Non-polar covalent bond or pure covalent bond. It is formed between two similar atoms. That means same electronegative. Here electronegative different, but here same electronegative. Example H2, H bond H. Both are similar atoms. That's why electronegativity is same. That's why bond pair of electrons exactly center between two atoms. But in this case, in polar covalent bonds, the bond pair of electrons near to the more electronegative atom. But in case of non-polar covalent bond or pure covalent bond, the bond pair of electrons exactly center between the two atoms. Okay. Now example Cl bond Cl. This is also pure covalent bond or non-polar covalent bond. Next F2, F bond F. This is also pure covalent bond or non-polar covalent bond. Okay. O double bond O. That is also pure covalent bond or non-polar covalent bond. Okay. So non-polar covalent bond means it is formed between two similar atoms. That means same electronegative. Polar covalent bond means it is formed between two different electronegative atoms. Example, here hydrogen and fluorine, they are having different electronegative values. The bond pair of electrons attracted towards more electronegative atom. Okay, more electronegative atom. That's why this one here fluorine more electronegative. That's why the bond pair of electrons near to fluorine atom. So fluorine gets partially negative charge, hydrogen gets partially positive charge. Polar. Okay. Next, some molecules having both polar and non-polar bonds. Example H2O2. In hydrogen peroxide, both polar and non-polar bonds present. H2O2 structure. This is the structure of H2O2. This is polar covalent bond. Why? Because this bond between two different electronegative atoms. This is also polar, two different electronegative atoms, oxygen, hydrogen. This is non-polar. Because similar atoms, same electronegative. So in H2O2, both polar and non-polar bonds present. Next one, N2H4 hydrazine. This one, structure of hydrazine. This is the hydrazine. Between nitrogen and hydrogen, this is polar, because hydrogen and nitrogen electronegativity different. Which one non-polar? This bond is non-polar. So these are some examples having both polar and non-polar bonds. Okay, na?